So I'm going to talk about some, not all, because there's not time to do all, but I'm going to talk about how NSF goes about funding database management systems technologies through research, development, and deployment. And I should say that I'm a program manager in the computing directorate at NSF, where we're focused primarily on the research side of this. Okay, so NSF supports both basic research and database management technologies, primarily in the computing directorate, some other places as well. We also support development of reusable software tools, data management tools, and we support deployment of large-scale database management systems for large instruments, accelerators, telescopes, other sorts of things like this. So in the research sector, this is mostly in size, the computing directorate, and there are two major programs here. The IIS Core program, which is divided among a number of clusters, the III cluster, Information Informatics and Intelligent Information Informatics, supports database management systems, data mining, information retrieval, semantic web, bioinformatics, some other things. And there's another group, Robust Intelligence, which supports machine learning work. This program runs, III runs around $17 million a year for new solicitations. And for FY13, and we're hopeful that we'll have similar sort of budget in FY14. We don't have a budget yet. There was in FY12, and the processing spilled over into FY13, there was a big data solicitation, which emphasized large-scale data management and data analysis applications. This was a joint program with NIH, and between FY12 and FY13 combined, there was about $30 million in NSF awards. The FY12 competition, which was partially funded out of FY13, was joint with NIH. In FY14, the expectation is that NIH will run their own big data solicitation. I believe it's actually on the street already. So NSF will be running a separate solicitation, not joint with NIH. And that solicitation is still pending. It hasn't been posted yet. So for the database management research, the primary evaluation criteria are novelty and significance. And we support both online transaction processing work and analytics type databases, although we tend to do more analytics stuff. And certainly in the big data, that is almost entirely focused on analytical applications rather than transaction processing. In the core solicitation, these proposals range from $500,000 to $3 million. There's another program called Expeditions where they range up to $10 million. And the duration of these awards is 3 to 5 years. The panels are typically 1 to 2 days with half a dozen to a dozen panelists. They're dominated by academic computer science researchers, some industrial database researchers, and a few industry developers. These panels tend to be reluctant to fund large-scale development projects and benchmarking things. So this is really mostly small-scale research and the emphasis on the development of novel techniques and data structures and things like this. So then the question is, well, if you've developed a prototype, say, and the software that comes out of the research side is is primarily research prototypes. It's not intended necessarily for production work. There's another program called Dibs, Data Infrastructure Building Blocks Program. This is run out of the Advanced Cyber Infrastructure Division of SIZE. It used to be a separate office, the Office of Cyber Infrastructure. And their charter in this program is to develop software tools that are reusable across multiple scientific disciplines. And a lot of this work is focused on transitioning the transition between database management, research, and production. So, and they're concerned with the entire life cycle of database management, that is conceptualization, implementation, and interoperability issues. Their budget last year was about $27 million. And the solicitation, again, is still in development and hasn't been posted yet. These awards vary up to $5 million for 4 years. So they're somewhat larger awards that can support development projects. The panels are, again, about the same, small, half dozen to a dozen panelists, 1 to 2 days. The panelists here, rather than being academic computer science researchers, tend to be more database management system developers, users, database administrators, and so forth. The primary review criterion is the utility of the resulting software to multiple research disciplines. The PIs here may be database management researchers, or they may be developers. And the program directors are Robert Shattuck and Amy Walton. Now, I have their contact information at the end. So this is the primary program for development of significant scale software that's intended to actually be usable by people in the scientific communities. And then the third phase is that NSF also supports the development of, or the deployment of database management systems, typically in support of large instruments, telescopes, accelerators, various kinds of observatories for gravitational or neutrinos or other sorts of things like this. And they also support database management software for large data acquisition programs, such as the NEON program in the Bio Directorate, EarthCube in the Geosciences Directorate, and National Center for Atmospheric Research in the Geo Directorate. Here, particularly in the large instruments, we see that the database management systems development is often bundled with the instrument proposals. So, for example, for large telescopes, you won't have a separate solicitation typically for the data management software. It will be bundled into the solicitation and the proposals for the actual telescopes. These are very long development cycles. Roger alluded to the Atlas development cycle here earlier this morning, but 5 to 10 years, sometimes 15 or 20-year development cycles for really big projects are not uncommon. The review panels are much larger. They typically range in size to something like 40 panelists. The reviews are longer. They run an entire week. They often decompose into subcommittees to consider particular issues. So there may be a subcommittee that's worried about data management for a large facility. In contrast to the research programs, here, because the object is to build and operate a telescope, not to do database research, the program directors tend to be fairly risk averse, and they prefer more mature database technologies. And they're frankly uneasy when people come in and propose a brand new database management system that's, say, still in development. So the big instruments are done by separate divisions in NSF in the domain sciences. Astronomy handles the telescopes, both radio and optical telescopes. Physics is doing things like LIGO, which is this gravitational wave observatory. The Bio Directorate tends not to be focused on large instruments so much as aggregating multiple data sources. Geosciences also handles multiple. They have some things involving handling satellite data, Landsat data, and things like this, but they also collect many different data sources. I'll say more about that in a minute. Here, the review criteria are the utility of the data management system for the particular project. So in contrast to Dibs, which is looking for database technology which is useful across multiple scientific disciplines, if they're funding a big telescope, what they care about is how well will this support this particular telescope and the research on it. The review criteria, in addition, is they're concerned with software maturity. They're building a telescope which costs a couple $100 million. They don't want it to fail because a $10 million database project turns out not to work reliably. They care a lot about reliability. Accelerators cost tens or $100 million a year to run. And if you're not taking data, you're wasting a big instrument. In the case of the telescopes, I think their operating budgets are somewhat less, but there you have the issue that if your database management system can't take the data, you may miss interesting observations. If a star goes supernova and you can't save that data, then it's gone. It's not reproducible. They care about performance. Roger gave some of the data rate estimates earlier in the morning here. These things are pushing the envelope on what's feasible in large-scale data management. And they care about support services. And I'll say a little more about that in a moment here. They also care about ease of modification. So one of the issues that's arisen with commercial database management systems is they typically have a release cycle of, let's say, once or twice a year when they fix all the bugs that they've accumulated. And if the bug is actually disrupting operations on a large instrument, on an accelerator or a telescope, they don't want to wait half a year to fix that bug. And so they're somewhat more receptive to open source database management systems than they otherwise would be, because they typically have a team of their own developers supporting this, and if they run into a serious bug, they can put people on to fix it immediately, whereas if it's a large commercial DBMS company, they may be one fairly small contract for a very large corporation. So that's been one of the major interests in using open source software. They also need to extend the functionality sometimes. And the other thing, as Roger alluded to earlier this morning, these collaborations are often huge, involving dozens or hundreds of institutions and thousands of collaborators. And the licensing costs for commercial software is often a significant impediment. Let me go back a minute here. The other thing that's worth saying here is that it strikes me that there are really two kinds of large-scale database deployments. There are the ones that are intended to support single instruments, accelerators, telescopes, and so forth. And these people have a somewhat simpler problem. They may have serious performance problems, but they don't have many of the data integration problems that afflict the more small-scale science organizations, such as the biosciences and the geosciences, where they often have to integrate many different data sets together. And so they have a lot of problems with data integration. And in particular, there's a program at NSF called EarthCube by the Geosciences Division, and they're spending a lot of time and money looking at semantic modeling of Earth science data, and how do you integrate different data sets from typically different satellites. And this is also a big problem in the biology community. So what I want to emphasize is that the deployment the database deployment solicitations, as I said, they're typically bundled with the large instruments, and they're run entirely out of the domain science divisions at NSF. So the panelists on these panels will typically be users or people who are running other large instrument data centers, either for DOE or for NSF or from Europe or something like this. And they're typically, they may have database developers on these panels, but you typically will not see academic computer scientists on these panels. And they view these things as deployments, or possibly, if they have to, development projects, but they don't view it as something that's particularly receptive to doing computer science research. They may be forced into novel database systems for performance reasons, but it's not their goal to push the envelope in that direction. And they're quite uneasy with novel database technology in many cases because of concerns about whether this will actually work when they need to deploy it. Let's see. Acknowledgements to some of my colleagues here and contact information for some of these programs. I should say that this is by no means a complete list of the database management research programs at NSF. There are increasingly data management research programs tucked away in almost every directorate now, because data is becoming an increasingly central part of the research activities and portfolio of National Science Foundation. In particular, there's another big data program called CDS&E, I've forgotten what the acronym stands for, and it's a big data program that's run out of the Math and Physical Sciences Directorate, and it tends to be more applied than the one that's run out of size. And I'll be happy to take questions if people want to ask about either the CS research, the database research programs, or the development or the deployment sorts of things. But we have all three of these activities at NSF. The deployment activities tend to not be as visible because they're buried inside the domain science programs. And the other thing is, aside from the IIS core solicitation, the big data solicitation and the Dibs solicitation are not out yet, but will probably be out in the next, I would guess, 1 to 2 months or something like that. NSF doesn't yet have a budget for FY14, so we don't know the size of these programs and things like this. But they tend to be reasonably stable. The big data program's relatively new, but it will probably run another year or two at least, if not longer. Questions?